All right, let's jump right in. We usually think of AI as this total black box, right? Just a crazy web of code and data that somehow works. But what if I told you that underneath all that complexity, there's a hidden blueprint, an incredibly elegant mathematical structure that explains how AI really learns? Well, today, we're going to pull back the curtain and uncover that secret.
And to kick things off, I've got a bit of a riddle for you. What does a learning AI, a self-regulating kitten, and, get this, data flowing through a program all have in common? I know, it sounds like a joke, right? What on earth could possibly link those three things? Just stick with me here, because the answer, well, it might just change the way you look at, well, everything.
See, the connection here isn't just some clever little party trick. It's something that researchers are starting to call one of the most profound secrets of modern science. So here's the secret. All of these systems, we're talking biology, technology, you name it, they all learn and adapt using the exact same abstract pattern. It's like they're all built from the same universal blueprint for how to respond to the world and get better over time. Okay, so to really get our heads around this blueprint, we've got to start with something you've probably heard of. It's really the bedrock of how pretty much all modern neural networks learn. And that process is called backpropagation. The simplest way to put it, it's how a network learns from its mistakes. The key idea, the thing you really need to remember, is this concept of propagating changes. Basically, it sends a signal about its screw-ups backward through all its layers to figure out how to do better next time. This really shows you the whole flow, right? The network gets some data, it makes a guess, and then it looks at the result and goes, oof, how wrong was I? That moment, calculating the error, that's the magic sauce. That error signal is what gets sent all the way back, step by step, whispering to every single part of the network, hey, you need to tweak yourself a little bit for the next round. It's this beautiful cycle. Guess, check, and correct. All right, so seeing this in an AI, that kind of makes sense. But how in the world do we connect that to a kitten or to a data structure? Well, for that, we need a totally new language, a much more powerful one, designed for one thing, seeing hidden patterns. And that language is called category theory. Now, I know that sounds super intimidating, but don't let the name fool you. Think of it less like scary abstract math and more like a pair of X-ray specs. It's a toolkit that lets you see the deep, shared skeletons that connect things that look totally different on the surface. It helps you see the forest for the trees. I mean, just look at this list for a second. On the surface, what could a neural network possibly have in common with how a living creature regulates itself? Or what connects economic games to how data flows through a computer? Seriously, they feel like they're from different universes. But with category theory, you can strip away all the surface-level details, the neurons, the cells, the lines of code, and you can actually see the blueprint underneath. You see the abstract shape of how they all work. It really is the ultimate tool for finding hidden patterns. So what is this abstract shape of learning anyway? What does it look like? Well, to figure that out, we can take this powerful new language and point it directly at that backpropagation process we were just talking about. And look, this isn't just some cool, fluffy idea. This is grounded in some really serious research. There's a landmark paper by Brendan Fong, David Spivak, and Remy Tuyères that just laid this all out perfectly. And the title itself, it gives away the whole game, Backprop as Functor. So, what the heck is a functor? Well, it's one of the most important tools in the whole category theory toolbox. The absolute best way to think about it is like a universal translator, but for systems. It doesn't just translate words one for one. No, it translates the entire grammar, the entire structure. It's a map that shows you, with mathematical precision, how the blueprint of one system is exactly the same as the blueprint of another. And this right here is the absolute core insight. This is the big aha moment. By using a functor, these researchers proved that backpropagation isn't just some random algorithm that happens to work. No, it has a specific, reusable, abstract shape, like a mathematical fingerprints that you can spot anywhere, in any system. Okay, now we can finally put all the pieces of the puzzle together. It's time to solve that riddle from the beginning. Remember where we started? The AI, the kitten, and the computer program. Now that we have the right tools, the answer is right in front of us. This is it. This chart lays it all out. Just look at the pattern here. In the world of neural networks, the process we care about is supervised learning. Over in cybernetics or biology, it's self-regulation, like a kitten constantly adjusting to keep its balance. And in computer science, it's the flow of information. Now, on the surface, those are completely different things. But when we put on our category theory glasses, we see something incredible. The deep structure, the blueprint for how they all adapt and respond to feedback, is exactly the same. Don't worry about the fancy names in that last column. What's mind-blowing is that backprop is Functor, cybernetic kittens, and pro-functor optics are all just different names for the very same abstract shape.
And believe it or not, this is just the tip of the iceberg. This whole idea is part of a massive, emerging field of science. This same kind of blueprint hunting is popping up all over the place. It's helping us build a unified theory of complex systems, connecting ideas from economics, biology, and even physics. It's huge.
So, what's the big takeaway here? What should you walk away with? It's this. Learning isn't some magical, mysterious thing that only happens in brains or fancy AI. It's a fundamental pattern in the universe, a universal process of adaptation, of correction, that seems to be woven into the very fabric of how complex things work. And that leaves us with one last, really fascinating question to chew on. If something as complex as learning has a universal shape that connects living things to machines, what else out there is secretly the same? What other mind-blowing connections are just hiding in plain sight, waiting for us to find the right language to see them?